Hello everyone. I, Anamika Tiwari, along with my teammates Abhay Tyagi and Darshita Shukla, going to present our final year project under the supervision of Archana Sharma, Assistant Professor, Department of Computer Science and Engineering. Our group ID is 34 and title of our project is Detection of Depression Related Posts on Social Media. Now let's begin with the problem statement of our project. Diagnosis of mental illness is becoming a big concern, because of which many psychiatrists find it difficult to detect the presence of mental illness in a patient. Millions of people worldwide suffer from depression. These mental diseases are frequently hidden by their careers, making early depression diagnosis more difficult. This problem can be addressed using popular social media platforms. Moving on to the aim of our project, depression is viewed as the largest contributor to global disability and a major reason for suicide. It has an impact on the language uses reflected in the written text. The key objective of our study is to examine Twitter users' posts to detect any factors that may reveal the depression attitudes of relevant online users. Due to the huge increase of awareness of mental health well-being, the detection of mental illness itself is starting to become a huge concern. However, due to the integration of social media into people's daily life, this creates an environment that may provide additional information regarding the mental disorder a patient bears. In this project, we have implemented 5 machine learning algorithms, namely SVM, decision tree, KNN, naive Bayes, and random forest, on 2 text feature techniques, that is TF, IDF, and bag of words. Wow. Now we are moving to the literature survey. I'm going to discuss all the results from the various research papers that we have read in order to understand the problem statement as well as the previous research done on the given topic. This helps us to understand the limitations of previous approaches and their accuracies along with the precisions. In the first reference, when using different word embedding approaches with bidirectional long short term memory, precision of 0.78 was obtained. With LSTM and NLP techniques, the final model accuracy was turned out to be 95.8% with an F1 score of 96%. With deep learning socially mediated patient portal, we found the accuracy to be of 86.393%. The tokenization of n-grams and machine learning gave the precision of 0.64. N-gram machine learning and deep learning techniques gave the 50% accuracy. And for the last one, that is with deep learning, NLP, and SVM, we found the F1 score to be 0.99731 along with the accuracy of 0.99265. On social media data, various machine learning techniques to extract a user's mental health state with an emphasis on depression have already been used. One of the most effective approaches to diagnose sadness is looking for sentences in the data that reflect negativity. In this paper, we have implemented 5 machine learning algorithms, namely SBM, decision tree, KNN, naive Bayes, and random forest, on 2 text feature techniques, that is TF-IDF and bag of words. Our combined approach using TF-IDF and BO is producing better results in terms of accuracy and precision than past implementations of the previously published research papers. Our implementations involve all the users of TF-IDF and BO collectively with all the above mentioned machine learning algorithms in which SVM had the highest accuracy of 99.7%.
Now, let us proceed with the running model of our project. The first part of our project involves the implementation of PHQ-9, that is, the Patient Health Questionnaire. It is not a screening tool for depression, but it is used to monitor the severity of depression and response to treatment. However, it can be used to make a tentative diagnosis of depression in at-risk populations, example those with coronary heart disease or after stroke. The Patient Health Questionnaire is a new instrument for making criteria-based diagnosis of depressive and other mental disorders commonly encountered in primary care. The diagnostic validity of the PHQ has recently been established in two studies involving 3,000 patients in 8 primary care clinics and 3,000 patients in 7 obstetrics gynecology clinics. Here, in this window, I have selected the relevant options to the questions in order to determine the severity of depression of a person. This is the result that we have concluded by the selected options. Now, let us proceed with the sentiment-based test that involves the implementation of the previously mentioned 5 machine learning algorithms, namely SVM, decision tree, KNN, naive Bayes, and random forest on 2 text feature techniques, TF-IDF and bag of words. The data set has 3 fields: the label representing the tweet's polarity, IDs, that is the serial ID of the tweets, and the text. An approximate estimate was made that the data set would be classified between 75% data for training and 25% data for testing. Now, I am going to use some phrases according to which it will be derived that the user is depressed or not. As the result says by the phrase, you are facing depression. Now, let's do another example. As the result shows by the phrase we have used that you have no depression. Moving on to our results. The TF-IDF and BO extend different accuracies for SVM, decision tree, random forest, naive Bayes, and KNN models. The accuracy is 99% in all cases except for the naive Bayes model. As a result, we found that in comparison to all other models like decision tree, which provide accurate results of 99.4%, random forest of 99.5%, naive based, which gives an accuracy of 96.6%, and KNN with an accuracy of 99.6% as well. SVM gives the highest accuracy of 99.7%. The implementation of feature extraction techniques of TF-IDF and BO has been made collectively with all the above mentioned machine learning algorithms. Social media plays a great role in determining how individuals communicate with each other and express their feelings. The use of social networking platforms like Instagram, Meta, and Twitter to express one's feelings has become quite popular. Using the right approaches, we can figure out what the user's true feelings are. In our study, we found that combining SVM, KNN, decision tree, random forest, and naive Bayes with TF-IDF and BO feature extraction approaches considerably aided us in correctly recognizing the user's depressing attitudes. We have compared the performance accuracies of all 5 models after pre-processing and analyzing of the imbalanced tweets dataset. Among all the algorithms, SVM results in the best accuracy of 99.7%. These are some of the references that we have used in our research. Thank you.